Hey everyone, welcome back to Tech and Take. This channel is my small step towards achieving something big, to share the useful tech knowledge with clarity and simplicity. If you find value here, a like or subscribe really motivates me to keep going. Let's get into today's topic.
Today, we are going to understand Amazon SQS, nothing but simple queue service in a very simple and practical way. We will see why SQS was introduced, what problem it solves, how it works, real world usage, and then we will go into advanced concepts like visibility timeout, DLQ, FIFO, scaling and more, maybe in the part 2 session. By the end, you will be able to explain SQS confidently in any interviews or real world scenarios. Earlier, applications were built as monolithic systems, where every part of the systems was tightly connected. When application becomes bigger, companies started using microservices architecture to split features into separate independent services. But this created a new problem. Like services need to send data to each other. Sometimes one service sends data faster than the other can process, or one service may go down or slow temporarily. So this caused message loss, system crashes, and performance bottlenecks. So we needed a reliable way to send messages asynchronously without losing them and without depending on whether the receiver is alive at that moment. This is where message queue came into picture, and AWS introduced SQS to solve this problem in a simple and scalable way. Let's understand what is AWS SQS in detail. It is a fully managed messaging queue service that allows us to decouple applications and build distributed systems. Using SQS, we can send, receive, and store the messages without losing them. Here, sender A starts sending messages into queue. So we call sender A as a producer because it sends the message into queue. Whereas this SQS queue act as a middleware between the sender and receiver. So this is our queue here. And consumer. Consumer is nothing but the receiver here, which receives the data from the queue. So when it comes to a real-time application, say for example, the sender A and receiver B will be lambda. Okay, sender A sends a message to another lambda using queue. So A will be a producer, B will be a consumer. We have two kinds of queues. One is standard queue and one more is FIFO queue. Standard queue supports a nearly unlimited number of transactions per second. Message delivered at least once. And best effort ordering means message might be delivered in an order different from which they sent, which means the order not guaranteed here. And one more type is FIFO queue. So in FIFO queue, like all the features we have in standard queue are similar. Along with that, in FIFO queue it guarantees the order processing, which means it follows first in, first out. And also it prevents duplication of messages, means message with the same content or with the same message ID are discarded. So this is the difference between standard queue and FIFO queue.
Thanks for watching. If you found this video helpful, please give it a like and don't forget to subscribe.